In this video, we will solve questions on drawing resonating structures. So let's start this video. The question is, write the resonating structures of the following. You can also be this question can also be given in the form like draw the resonating structures of a given compound, or draw the canonical structure of the given compound, or draw the structure that has charge in it. Of the various resonating structures. So let's start with phenol. Phenol has this structure. Let me draw it a little bit. This is the structure of phenol. OH. There are two lone pairs here. Now please remember, the OH group is electron donating by resonance. So what will happen? The electron pair which is present here, they will donate electron to this bond, and when it donates electron here, a double bond will be formed. So 2 bond here, 2 bond here, 2 2 4 plus 1 5. Here that means this is a carbon atom. Carbon cannot form 4 bonds. 5 bonds. It can form only 4 bonds. So that's why this double bond has to shift here. So we will put a double-headed arrow and draw the next resonating structure. So here double bond will be formed, OH, because this electron pair has come to here, so plus charge will be there, and this pi electron will come here. Okay, and the rest of the structure will be same. Now in the second structure, what will happen? This electron pair will act on the adjacent bond, and this pi bond will shift to the pi electron will shift to the adjacent carbon atom. So the structure will be something like this. Same OH. A double bond will be formed here, and because it will shift at this position, so now in the next structure what will happen? This will attack at this position, and this pi electron will shift here. So we have double bond here, and the pi electron will shift here. Now this will be as it is, plus charge here. Now finally this electron pair will attack at this position, and this will go here. So we will have this structure. So we have 1, 2, 3, 4 and 5 resonating structures. Now due to this resonance, what has happened? See, the position of double bond has changed. Initially it was 1, 2, then 3, 4 and 5, 6, but after resonance the position has changed. This has become, the double bond's position has changed. So resonance gives stability to the molecule. So these are the resonating structures, and out of these 3, that is 2, 3 and 4, they have charge. So sometimes you may be asked to write only the structures bearing charge, and all of them are canonical structure. So this is the solution of the first question. Now initially you may face difficulty in writing these structures, but on practice you can have hold over it. So let's move on to the next question, that is nitrobenzene. One thing, OH is electron donating due to resonance here, but due to induction it will be electron withdrawing. But in this question we are supposed to write the resonance, so we will consider only that effect. Nitrobenzene. This is the structure of nitrobenzene. Double bond O, and lone pairs on the oxygen atom. Now to be able to write the resonance structures, it is very necessary that you know how to write the Lewis structures. If you are able to write it correctly, then only you will be correct in writing the resonating structures. So this NO2 group, you know, it is electron withdrawing in nature. So what will happen? This pi electron, it will give before that this pi electron will shift here, and as a result the pi bond or the pi electron between nitrogen and oxygen, it has to shift here. So we will have a structure like this. Now one more thing which I should say, that in case of phenol, we had seen that the electrons are entering into the system. Okay, so when electrons enters into the system, it is called plus R effect. Plus, because it is increasing the electron density inside the benzene, and R for resonance. Now here what will happen, it is taking away electrons, so it's a minus R effect. So the second structure will be, obviously a double bond will be formed here. Now single bond, or initially there were 2 electrons, and 2 electrons have come from the double bond, so a minus charge will be formed, and here a plus charge will be introduced. Now with what will happen, this plus charge will attract the electron towards itself, the pi electron, they are the weak electrons. So we will have a structure like this. That is oxygen, this minus, and a double bond here, and plus in this side. So this is the third structure. In the fourth structure, what will happen, this will come here. So we will write, and the plus charge will come to this place. Same, and finally this has to come here, and this minus charge will to give electron here to satisfy the valency, and finally we will have a structure where the bond position will change. So these are the 5 resonating structures of nitrobenzene. Okay, so this shows minus R effect because it is taking away the electron density. Now let's move on to benzaldehyde. Benzaldehyde, this is benzene ring, and the top of it we have C double bond O and H. Okay, so benzaldehyde, this CHO group, this is also, you know, electron withdrawing. So what will happen, this pi electron will shift, and as a result these electrons has to come here. So a double bond is formed here. We will write oxygen, now 6 electron, and minus charge, and plus charge will be introduced here, same like the nitrobenzene. So in the next structure, this will get attracted towards this position. The pi electrons are weak electrons, that's why it is happening. H. Okay, so double bond will shift here, plus sign will come here. In the next structure, this will attack at this adjacent position, and we will have, it's very easy, you just need practice. It might look difficult, but if you give a good look to the structure, you can find that they are not difficult. What will happen? And finally here this plus charge will come, and these electrons will attack here, and this will come here, and we will get this final structure. Okay, so these are the 5 resonating structures of benzaldehyde. 1, 2, 3, 4, 5. Okay, so let's move on to the next question, anisole. And this is also minus R effect. So anisole, the structure of anisole is this, COCH3, that is O here and CH3 is here. 1, 2, 3, 4, 5, 6. So what will happen? Let us take these double bonds. This will give its electron here, this has to shift here, so we will get a double bond will be formed here, plus charge will come here, and this pi electrons. Next, these pi electrons will attack at the adjacent position, these electrons, and the pi electron next to it will attack at the adjacent carbon. So we will have the next structure. Double bond here, and so next what will happen? This will attack at this position and it has to come here. So here one double bond, here the electron pair will come here, next plus charge CH3. So finally this will attack here and this has to go there. So we will have change in bond positions. So this is OCH3. Okay, so 1, 2, 3, 4 and 5. So these are the 5 resonating structures, and these 3, and you will see generally this 2, 3 and 4 structure, these are the one which will carry charges. And finally the benzoic acid. So benzoic acid, benzene ring has what? It has COH over it. So this is benzene ring. We will write C double bond O and OH. Okay, and the alternate, always remember we are writing resonating structures for conjugated system. Conjugated system means a system which has alternate single and double bonds. So here also this COH is electron withdrawing, so this pi electron will come and it will come here. So we will have the first structure like this, double bond will be formed here, and this oxygen will have minus charge, so here plus. So this second one, this is number 1, this is number 2. This pi electrons will get attracted towards this plus charge. So a double bond will be formed here, plus charge will migrate to this position. Okay, then this will attack at this position. Rest of the structure is same. This plus charge will come here, and finally they will donate this electron, and this 5 electrons will come here, and we will get back the initial structure, but bond position will change. So these are the 5 resonating structures of benzoic acid. So in this video we have learned how to draw the resonating structures of 5 important molecules: phenol, nitrobenzene, benzaldehyde, anisole and benzoic acid. There are many more. In your NCERT book you are given the resonating structure of aniline, that is NH2 is attached to the benzene ring, that is C6H5NH2. Go through it in the NCERT book and solve many more questions for good grasping. These are the important ones.